typos, and messy names can destroy exact match search. RapidFuzz gives you fast, fuzzy scoring, but the real win is choosing thresholds that do not overmatch. This is the setup you'll be able to run after this, which indexes names and fuzzy searches a typo-heavy query with a score threshold to return the best match. I'm Professor Pi, teaching search and IR with simple Python. Fuzzy search is what you reach for when exact matches fail. Users mistype names. Databases store names in different orders. Success means returning the intended record quickly and without a flood of wrong matches. RapidFuzz is a Python library built for that job. It gives you several scorers and fast matching primitives, so you do not have to invent string similarity from scratch. At a high level, fuzzy search scores how similar two strings look. A high score means they probably refer to the same person. Different scorers reward different patterns. Some focus on substrings. Some ignore token order. We will use a small name list and a few query examples so you can see how each scorer behaves. We will build a compact name index. Try a typo-heavy query. Handle short or clipped inputs. Filter by a threshold, and make the match order robust. This maps directly to cleaning login names, contact lists, and simple lookup services. Now we will try a simple example. This snippet finds the closest name match for a misspelled query using RapidFuzz. The list docs holds a few short name variants that mimic real user directories. The variable q contains a typo-heavy query, which is common in search logs. The call process .extract1 uses RapidFuzz to scan docs and return the highest scoring candidate with its similarity score. The scorer fuzz.WRatio is a weighted composite that balances partial and token-aware comparisons, making it a good default for names. The result best is a tuple of the winning string, its score, and its index. The printed best match and score confirm RapidFuzz can recover the intended name despite typos. Next, we will handle abbreviated inputs that lack full tokens. This example retrieves the best partial matches for a short query using RapidFuzz. The variable q2 mimics an abbreviated user input, which often lacks full tokens. The call process extract with scorer equals fuzz partial ratio focuses on substring similarity, so clipped forms like initials still match the right names. The argument limit equals 2 asks RapidFuzz to return only the top 2 candidates, balancing visibility with brevity. The list pairs strips out indices and keeps readable name score items. Increasing limit surfaces more candidates, but may include marginal options. Decreasing it tightens focus. The printed list shows how abbreviations still rank highly and remain interpretable. Now we will prune weak results with a threshold, so only strong matches survive. This code filters out weak fuzzy matches using RapidFuzz's score cutoff. It reuses the misspelled query q and applies process.extract with fuzz.WRatio while setting score cutoff equals 85, so only strong candidates are returned. The variable filtered contains all choices meeting or exceeding the threshold, and low captures the minimum score among those survivors. Raising score cutoff tightens precision, but risks missing valid near misses. Lowering it expands recall, but can invite noisy hits. The limit equals none keeps all qualifying matches for inspection or downstream ranking. The printed kept count and lowest kept score confirm that thresholding prunes weak matches while preserving solid ones. Next, we will match a name even when tokens are out of order. This example matches a name whose tokens arrive out of order by using RapidFuzz. The variable Q3 deliberately flips tokens and includes punctuation. The call process.extract1 with score equals fuzz.token-set-ratio ignores token order and duplicate terms. So variations like Johnson Alice align with Alice Johnson. This scorer is especially useful for names and organizations where order and punctuation vary across data sources. If queries are very short, token set ratio may overgeneralize. Pairing it with partial matching can help. The printed order robust match and score show that token level alignment recovers the intended person despite formatting changes. Now we will combine those ideas into a single search helper you can reuse. This code builds a compact search function that blends RapidFuzz scorers. The function search computes a dynamic threshold T that is stricter for longer queries and looser for short ones. For each candidate in docs, it takes the maximum of fuzz.WRatio and fuzz token set ratio. For short queries, it also considers fuzz.parcel-ratio to reward good substrings. Candidates meeting the threshold are collected, then sorted by score, and the top K are returned. Increasing K widens the result set. Lowering T boosts recall, but can introduce noise. The printed final top 3 shows a tiny, practical baseline that handles typos, order flips, and short queries. In a real system, this pattern slots into a name lookup service. Use a fast in-memory list for small directories. Move to an approximate nearest neighbor or pre-computed tokens for larger catalogs. The search helper still applies as a scoring layer. Fuzzy search with RapidFuzz is string similarity tuned for messy input. Use it when users type imperfect names or when sources store names differently. One caveat is threshold choice. Too low and you get irrelevant hits. Too high and you miss good near matches. Next step, tune the threshold function and scorer mix for your data by testing different score cutoff values and measuring recall and precision on a labeled sample. If short practical IR helps, subscribe and watch the IR videos.